Now that we know what a sample is, we're now going to learn how to make inferences from samples. Now we can use the sample to tell us information about the entire population, and in order to do that, we are going to use a proportion to help us figure that out. Now our proportion is when we have a fraction equal to a fraction. Now this first fraction is going to represent our sample, and this second fraction is going to represent our population. Now each fraction is going to have a part. So what part of the sample? Out of the whole. And we're going to have a part of the population out of the whole. Here's our first example. One moment, sorry. Okay, so our first example says that a video company randomly selected 100 of its subscribers and asked them how many hours of shows they watch per week. Now, of those shows, 35 watch more than 10 hours per week. Based on the data, if the company has 3,000 subscribers, how many watch more than 10 hours per week? So now we're going to set up our proportion. We've got a fraction equal to a fraction. Now again, our first fraction is going to represent our sample. So we selected 100 of its subscribers and asked them how many shows they watch per week. And so our entire sample is 100. Now of those surveyed, so we know out of the 100, 35 watch more than 10 hours per week. So we've got 35 out of 100. Now, based on the data, if the company has 3,000 subscribers, how many watch more than 10 hours per week? So we're trying to figure out, we're making an inference about the population based on the sample that we created. In a previous video, you learned about how to do this. There's two different methods. The first method is we could say 100 times what gives me 3,000. And we know that that's times 30. You can do this for every single proportion problem, but you cannot use addition or subtraction. You can only use multiplication and addition and division. So if we're going to multiply our denominator by 30, we're going to do the same thing to the numerator. So 35 times 30 gets us 1,050. Now the second way that we could do this is we could butterfly. We could cross multiply. So we could do 35 times 3,000. Well, you know what? Before we do that, let's simplify it. We do not have to work with numbers this large. 35 and 100, 5 goes into each of these numbers. 5 goes into 35 7 times, and 5 goes into 100 20 times. So we just simplified this fraction, and the purpose of doing so was so that we didn't have to work with 35 and 100. We now only have to multiply 7 times 3,000. Now 7 times 3,000 gets us 21,000. And 20 times x is 20x. We want to get x by itself, so we divide both sides by 20. And again, we get 1,050 as our answer. So again, there are two different ways. You can do butterfly, or you could look to see at the proportion. Great. Next question. Below is data collected from a random sample of 80 students regarding their elective performance. And you're given a table here, and it is important to be able to read through a table. So if the entire school has 400 students, then what is a reasonable estimate for the number of students who prefer music? Now, we know our sample is out of 80 students. And we know that our population is out of 400 students. We are trying to find out how many in the population based on our sample. Now the question is, who prefer music? So in the table, we see that music has 14, so we're going to do 14 out of 80. And we're going to do the same thing as before. There are our two methods from before, but 80 does not go into 400. Oh, I'm sorry. It does go into 400 evenly. So 80 times what gives us 400? And the answer is times 5. So we're going to do the same thing to the 14 times 5. 14 times 5 is 70. And so now we know that 70 out of 400 people in the entire school preferred music. Now, we did not survey all 400 people in the entire school. That's what the sample is for. It's much easier to sample 80 students than all 400. But we made an inference based on our data that was collected random, adequate, and representative in order to create this inference. We've got one more problem. Going with the previous example, we've got the same table. So of the 400 students, what is a reasonable estimate for the number of students who will not select art? This is an important question because of this word not. You will have questions like this asked in the future, and it's really to trick you up. So don't get tricked up by this word not. And that's why highlighters and underlining is really helpful on tests and quizzes. So again, we have our survey of 80 students. This is again from the last question, and our population is out of 400. Now this time we want to figure out how many do not select art. So 28 do select art. 38 plus 14 is 52. So there are 52 students that prefer PE and music, so not art. And again, we're trying to find out how many in our population. We're making an inference. So the numerator of our population is going to be our x. We just found from the previous problem that 80 goes into 400 5 times. So whatever you do to the denominators, you have to do to the numerators. 52 times 5 is 260. So 260 students do not prefer art.